Hi everyone, my name is Mehmet Akif. Today I will do my physics 102 experiment, which is examining the Faraday's law. In this experiment, I use a magnet coil with 320 number of turns at the multimeter and the ruler. In this experiment, I use magnet to change the magnetic field in the coil and measure it with multimeter as an induced EMF. The aim is to find the magnetic field that magnet produces. To this, I use the ruler to take some of the heights. Then I will drop the magnet for different heights. After that, the measurements will give me some data about the induced voltage that coil produces because of the change of the magnetic field according to Faraday's law. Let's start. While I'm making this experiment, I collected data from the multimeter and then filled the table. I repeated this experiment for several times in order to increase the precision. After the table is filled, I plot the graph for induced voltage versus height, uh, and I observe the square root behavior of the graph. Here you can see the theoretical values and the experimental values. In order to make some calculations from graph, I also plot the square root of height versus induced voltage, and then I use the equation to calculate the magnetic field. After calculating the magnetic field from the experimental graph, I also compared it with the magnetic fields that measured by the Gauss meter. From this measurement, the error rate becomes 26%, which is not bad. The cause of this error might be due to the several reasons. First one is the air friction, which is ignored by me. As I dropped it from a certain height, it's exposed to a friction from the air. However, I ignored this in my calculations. That decreases the calculated magnetic field. Also, the multimeter frequency, the peak voltage cannot be really measured by our multimeter as it's not synchronized with my drops. Another reason can be the age of the coil and the multimeter. Our components are a bit older, so the data might not be so accurate. Also, I had to drop the magnet at the center of the coil, but I may not be able to pass it through the really center of the coil. That's my experiment. Thanks for watching.